Dear students, welcome. This is our second class on dynamics. Dynamics is included in the 5th semester CBCS course. We have already solved 6 problems. First of all, we shall try to solve these 2 problems. Before going to solve these 2 problems, I want to tell you one thing, that is x double dot. It is nothing but the second derivatives of x with respect to t. d2x by dt square. X double dot d2x by dt square this represents acceleration. Represents accelerations, or even is the mathematical expression. For acceleration in the direction of x increasing, x double dot d2x dt square is the mathematical expression for acceleration moving in a direction of x increasing. Similarly, x dot dx dt, this is the mathematical expression. This is the mathematical expression for velocity moving in a direction of x increasing. Direction of x increasing. It is a mathematical expression moving in a direction of x increasing. Just note these two. X double dot is the mathematical expression for acceleration moving in a direction of x increasing, and x dot is the mathematical expression for velocity in a direction of x increasing. Now, if sometimes if it occurs x double dot, the acceleration comes out to be negative, then you will conclude that actually x double dot is the mathematical expression for x increasing. If the particle is moving in a direction of x decreasing, then we will take the negative sign. And similarly for the velocity. Velocity means, x dot means it is moving in a direction of x increasing. But if it is noticed that the particle is moving in a direction of x decreasing, then we will take the negative sign. Just note it down. Now let us come to solve the 2 problems. Number one. What is the problem? A particle moves along a straight line, and at a distance x from a fixed point O on the line, its velocity is this. The velocity of the particle is this. X stands for the distance of the particle from a fixed point O. O is the, suppose O, this is the fixed point. This is a point x, at any point x. The velocity, suppose velocity of the particle here, this is equal to mu into c minus x divided by x under root. Prove that it is attracted towards O. we have to prove that it is attracted towards O. With a force inversely proportional to the square of the distance. It is attracted towards O means the velocity. Let me try to solve this problem. Acceleration x double dot always stands for the acceleration in a direction of x increasing, but the acceleration is equal to negative of something. Then we will say that the particle is moving in a direction of x decreasing. This means it is attracted. We are calculating x from the point O. We are measuring x from the point O. From the point O, the x will decrease. If x is decreased, then we will say that the particle is attracted. The particle is attracted towards the point O. Let us try to solve this problem. Given that velocity equal to, this is equal to mu root over c minus x divided by x. Velocity equal to mu root over c minus x divided by x. This means velocity equal to mu root over c by x minus 1. You may write like this. C by x minus 1. X by x is equal to 1. Just square it. Squaring we get v square equal to mu square c by x minus 1. You may write like this. Suppose this is number 1. Differentiating 1 with respect to x. Differentiating 1 with respect to x we get. Because the right hand side is a function of x. The expression is right hand side is of x, not t. If it is t, then we would have differentiated with respect to t. Okay. Differentiating 1 with respect to x, we get twice v dv dx. This is equal to mu square. This is constant. It will be minus c by x square. The differentiation of 1 will be equal to 0. This means v dv dx will be equal to minus c mu square divided by 2 into 1 by x square. You may write like this. V dv by dx. Now I told you that acceleration, the different expressions for acceleration is d2x by dt square. It is an expression for acceleration. dv by dt, differentiation of velocity with respect to t, dv by dt is also an expression for the acceleration. Also v dv by dx, it is also an expression for the acceleration. In the last class I told you. It was mentioned in the last class. Now let me go. This means acceleration equal to minus c mu square divided by 2 into 1 by x square That is, acceleration means x double dot. It stands for acceleration. 1 divided by x square. You see, x double dot is the mathematical expression for acceleration. For acceleration, moving in a direction of x increasing. The negative sign shows that the particle is moving in a direction of x decreasing, and it is attracted to us. And we are measuring x from the fixed point O. We are measuring x from the fixed point O. The negative sign shows that the particle is attracted towards O, the fixed point O. Also towards the fixed point O. Also, C mu square by 2 is constant. This means that acceleration varies inversely as the square of the distance from the fixed point O. We are measuring x from the fixed point O. From the fixed point O. Therefore, the acceleration varies inversely as the square of the distance Therefore, the acceleration varies inversely as the square of the distance from the fixed point O. Acceleration, for what is force? Mass into acceleration. F equal to ma, F is equal to ma, acceleration is equal to this. Multiply both sides by m. The force, it will be force. M is constant. Therefore, acceleration equal to minus sign. The negative sign shows that it is attracted towards O. Number 1. Number 2, since it is constant, this expression shows that the acceleration varies inversely as the square of the distance. X. What is x? It is the distance of the particle from the fixed point O. Therefore, it varies inversely as the square of the distance from the fixed point O. Clear? I hope you have enjoyed this. Now we have done question number 1. Just note it down. We have done question number 1. Now come to the question number 2. That is question number 8. Come to the question number 2. Today's question number 2 means question number 8. What is this? A particle moves from rest at a distance c from a center of force at a distance c and from rest, you see, from rest and at a distance h. Suppose this O is the fixed point. I am writing here O is the fixed point. It is moving. It moves from rest at a distance c from a fixed point. Suppose the particle starts from the point A and the distance is its initial distance, this c. OA is equal to c. It is given. Which repels means the particle is moving in this direction. Which a force this. The acceleration is given to be mu divided by x square per unit mass. Mu divided by x square per unit mass. Force per unit mass. This acceleration is equal to mu by x square per unit mass. Find its velocity when it is at a distance twice c from the center of force. Suppose B is a point such that this distance is equal to twice c. We are to find the velocity. Suppose the velocity is equal to Vv. Vv is the velocity of the particle at that point. What is this? O is the fixed point. We shall measure the distance from the point O. O is the fixed point. A is the starting point. Starting point means the velocity of the particle is equal to 0 from rest. Velocity of the particle is 0 and OA equal to c. You see. Also, with a force mu by x square per unit mass, we have to find the velocity of the particle when it is at a distance b. From when it is at the point B, it is at a distance twice c from O. This is the case. Let me write. Let O be the center of force. Let O be the center of force. O be the center of force. Again, let A be the starting point of the particle. A be the starting point of the particle. A be the starting point of the particle. O be the center of force and A be the starting point of the particle where OA is equal to C. Where OA is equal to C. The velocity of the particle at A is given to be equal to 0 because from rest, the velocity of the particle at A is given to be 0, is given to be equal to 0, to be equal to 0. 0. Velocity of the particle at A is equal to 0. Let P be the position of the particle. Where OP equal to X. Suppose P be the position of the particle, the distance OP equal to X. From here to here, this distance is equal to X. This distance is equal to X. The equation of motion of the particle is given by the equation of motion of the particle is given by the equation of motion of the particle is given by x double dot equal to mu divided by x square. X double dot equal to mu divided by x square. If the particle is moving, suppose if the particle is moving in this direction, this means if the particle is attracted towards the point O, then the equation of motion would have been x double dot is equal to minus mu by x square. Here the particle is moving in a direction of x increasing. Also, x double dot is the mathematical expression for acceleration in a direction of x increasing. Therefore, the equation of motion is equal to x double dot is equal to mu divided by x square. Right? This means x double dot. What is x double dot? It is acceleration. You see the right hand side is a function of x. You may write it as d2x by dt square or multiply both sides by twice dx by dt like this. Just we have done in differential equations. But you may write x double dot is equal to v dv by dx. You may write x double dot is equal to v dv by dx. You may write like this. This is equal to mu divided by x square. This means v dv equal to mu x to the power minus 2 dx. You may write like this, minus 2 dx. Now integrating we get. Integration v dv equal to integration mu x to the power minus 2 dx. You may write like this. X to the power minus 2 dx. This means v square integration plus the constant of integration. You may write plus c, where c is the constant of integration. where C is the constant of integration. Where C is the constant of integration. This means you may write V square divided by 2 equal to mu x to the power minus 1 by minus 1 plus C. C is the constant of integration. This means V square by 2 equal to minus mu by x plus C. Suppose this is number 1. This is number 1. Initially the particle was at A. Initially at A, the velocity was 0. The particle starts from A. The velocity of the particle at A equal to 0. When x equal to C, this distance was C. X is equal to C. Therefore, from 1 implies you will get 0 equal to minus mu by C plus. Oh, I am sorry. It should have been written C1, where C1 is the constant of integration. C1 is the constant of integration. You write C1 is the constant of integration. This means C1 equal to mu by C. C1 equal to mu by C. Therefore, substitute the value of the constant of integration in 1. Therefore, 1 implies V square by 2 equal to minus mu by h plus mu by c. This means V square equal to twice mu 1 by c minus 1 by h. 1 by c minus 1 by x. Suppose it is number 2. Suppose this is number 2. What is our aim? We have to find the velocity of the particle when it is at a distance twice c. Twice c. What is the velocity of the particle? Let B be a point. B be a point in the straight line. In the straight line, where OB equal to twice c. Where OB equal to twice c. Let VB be the velocity at B. Let VB be the velocity at B. VB be the velocity at B. We have to find the velocity of the particle at B. Therefore, putting V equal to VB and x equal to twice c into we get VB square equal to twice mu 1 by c minus 1 by twice c. 1 by c minus 1 by twice c. This means VB square equal to twice mu. It is nothing but 1 by twice c. 1 by twice c. This means VB square equal to mu by c. This means VB equal to root over mu by c, which is the required velocity of the particle when it is at a distance c from the center of force. Which is the required velocity of the particle which is at a distance twice c from the center of force, right? Of course, you may apply the definite integral also from 2. V equal to root over twice mu into root over of this. Just use V is equal to this. You have to find this one. Yeah. VB is equal to this. V square is equal to this. Before calculating the constant of integration, we got the relation that is V dV by dx, not V dV by dx equal to mu by x square. Mu by x square. we got this expression. Now, this means VdV equal to mu x to the power minus 2 dx. Now, let Vb be the velocity of the particle when it is at a distance twice c from the center of force O. This is the alternative method. Let Vb be the velocity. Vb be the velocity of the particle. Let Vb be the velocity of the particle when it is at a distance twice c from the center of force. When it is at a distance twice c from the center of force. Suppose this is number A. Integrating A we get. Integration V dV. This is equal to integration mu x to the power minus 2 dx. You may write like this. Initially the particle was at A. Then the velocity of the particle was 0. At that time, what is the value of x? OA, this distance was c. Therefore, it is c. When it reaches the point B, its velocity becomes Vb. Write it as Vb. And then the distance of the particle from the center of force O will be equal to twice c. Write like this, twice c. You may apply the definite integral like this. Just calculate this one. This means v square by 2. It is 0 to Vb. This is equal to mu x to the power minus 1 by minus 1. It is c2 twice c. This means half of Vb square minus 0 square equal to minus mu 1 by twice c minus 1 by c. You may write like this, or you may write half of Vb square is equal to mu 1 by c minus 1 by twice c. You may write like this. This means Vb square is equal to 2 times of mu. This 2 has been taken to the right hand side. It will be 1 by twice c. This means Vb equal to mu by c. Vb square is equal to mu by c. This means Vb equal to root over mu by c. The definite integral also can be applied to find the velocity of the particle when it is at a distance twice c from the center of force. Perhaps you have enjoyed this one. Let us take some more problems. Just note it down and let us take some more problems. Let us try to solve this problem. First question number 9. What is it? A particle of mass m is always acted on by a force towards a fixed point. It is always acted on by a force towards a fixed point, whose magnitude at a distance x from the point is this. Magnitude is this. But it is always attracted. If it starts from rest at a distance c from the point, prove that its distance will be c by 2 after a time this. What is its velocity then? Two questions. Number 1, let me draw that diagram first. Suppose O is the fixed point. This is the fixed point. O is the fixed point. And suppose A is the starting point of the particle. it starts from rest. A is the starting point of the particle, not only that. Starts from rest means velocity of the particle equal to 0. Starts from rest. This means the velocity of the particle at A equal to 0. And it is given that at a distance C, this means that this distance is C. OA distance, the distance OA is C. Velocity of the point A is A. Suppose P is the position of the particle at any time t. OP equal to X. OP is equal to X. Let me write this. First, let me write. Let O be the fixed point. It is a fixed point. It is called the center of force. Let O be the fixed point. A the starting point of the particle. Starting point of the particle. Where OP equal to, or where OA equal to C. It is given that OA is equal to C. It is given. Velocity of the particle at A equal to 0. It is also given. Velocity of the particle at A equal to 0. It is also given. Right? Now let P be the position of the particle at time t. Let P be the position of the particle. Let P be the position of the particle at time t, where OP equal to X. We always measure the distance of the particle from the point O. You should remember this. What is X? It is a distance of the particle from the point O. Now, you see, the mass of the particle is m. And fixed point, magnitude at a distance x from the point is this. Force, the force is this, m mu by x cube. The equation of motion of the particle is, at P is mx double dot. This is equal to, you see, m mu divided by x cube, but it is attracted towards the point O. What does x double dot represent? X double dot is the mathematical expression for acceleration if the particle is moving in a direction of x increasing. You see here, we measure x from the point O. If a particle is moving in this direction, x will be decreasing. If a particle is moving in this direction, x will be decreasing. But x double dot stands for the acceleration moving in a direction of x increasing. Therefore, we will take a negative sign here. Right? A negative sign should be there. Clear? Is it clear? Now, this means x double dot equal to minus mu x to the power minus 3. You may write here x to the power minus 3. What we are going to do? We are going to find the velocity of the particle when it is at a distance c by 2 from the center of force. When it is at a distance c by 2 from the center of force. Number 1. And number 2, what is the time taken by the particle? To reach a point in the line which is at a distance c by 2 from the center of force. These are the questions. Now, x double dot is equal to this. Now you see, first we have to find the velocity of the particle. This means if you may write v dv by dx for this mu x to the power minus 3. V dv by dx equal to minus mu x to the power minus 3. You may write like this. Because v dv by dx is an expression for the acceleration. We have applied this expression because the right hand side is a function of x. Right hand side has been expressed in terms of x. Therefore, we have taken the acceleration as v dv by dx. Right? Now, let me do this one. v dv by dx equal to this. This means v dv by dx. v dv equal to minus mu x to the power minus 3 dx. Minus 3 dx. Suppose this is no integrating we get. Integrating we get. You may write the integration sign. Integration v dv will be equal to definitely v square by 2. If you integrate this, it will be v square by 2. This is equal to minus mu. If you integrate this, you will get x to the power minus 2 divided by minus 2 and plus c1 by 2. You may write c1 by 2 where c1 by 2 is the constant of integration. Where c1 by 2 is the constant of integration. C1 by 2 is the constant of integration. Where C1 by 2 is the constant of integration. This means v square equal to mu by x square plus C1. Suppose it is number 1. This is number 1. Now you see, initially the particle was at A. At that time x is equal to C, O is equal to C. At that time x is equal to C. Initially at A, the particle was at A and the velocity of the particle was 0, v equal to 0 when x is equal to C. When x is equal to C. Initially this when x is equal to C, right? V is equal to 0 when x is equal to C. Therefore from 1 we get 1 implies, you may write 1 implies. This stands for substituting v equal to 0, x is equal to C in 1, we get, instead of writing all these things, just write 1 implies. This 1 implies. You will get 0 equal to mu by C square plus C1. This means C1 equal to minus mu by C square. C1 is equal to minus mu by C square. You may write like this. Now substitute the value of C1 in 1 we get, therefore 1 implies. Again 1. Substituting the value of the constant of integration C1 in 1 we get, instead of writing all these things, write 1 implies. V square equal to mu by x square minus mu by c square. You may write like this. V square is equal to this. Right? Now, this means V square equal to mu 1 by x square minus 1 by c square. Write it as number 2. Write it as number 2. V square equal to mu into 1 by x square minus 1 by c square. Write it as number 2. Now we are going to solve this, find the answer of this. What is it? What is its velocity then? What does it mean? What is the velocity of the particle when it is at a distance c by 2 from the center of force? from the center of force. Let suppose here it is another point. Suppose B. Suppose B is a point in the line OB, line OA, such that OA where OB is equal to C by 2. That means B is the middle point of, you may write it, B is the middle point of OA. You may write B is the middle point of OA. You may write like this also. Middle point of OA. You may let B is the middle point of OA. You may write it. Therefore, OB is equal to C by 2. Let the velocity of the particle at B be, let V1 be the velocity of the particle, be the velocity of the particle at B. Let V1 be the velocity of the particle at B. Now, putting V is equal to V1, x equal to, at that time, you will have to write x is equal to C by 2. C by 2. Velocity of the point. Therefore, putting V equal to V1, x equal to C by 2 into we get, you may write V1 square equal to mu 1 by C by 2 whole square minus 1 by C square. You may write like this. This means V1 square equal to mu, you may write here C square 4 minus 1. This means V1 square equal to thrice mu by C square. This means V1 equal to root over thrice mu divided by C. You have found one answer. Therefore, the velocity of the particle is root over thrice mu divided by C when it is at a distance C by 2 from the center of force O. You may write like this. Thus, root over 3 mu divided by C is the velocity of the particle, when it is at a distance, C by 2 from the center of force. From the center of force O of the fixed point O. This is the answer. Answer is this. One answer is root over 3 mu divided by C. It is number one answer. 3 mu, root over 3 mu divided by C is the velocity of the particle when it is at a distance C by 2 from the center of force. I think there should be no doubt. Root over 3 mu divided by C. One part has been solved. Now we are going to solve the other part. What is the other part? Prove that its distance will be C by 2. After a time dish, we are to find that time taken by the particle from A to B. This means time taken by the particle when it is at a distance x is equal to C to the point when it is at a distance x is equal to C by 2 is this one. How about C square root over 3 by mu? This one. We have to prove this one. Right. Second part. We are going to the second part. This is the first part. Perhaps you have noted down. Now from 2 we get from 2 we get V. This stands for x dot. V means x dot, velocity. This is equal to root over mu, root over 1 by x square minus 1 by c square. X dot is the expression for velocity moving in a direction of x increasing. You see here, now you see the particle is moving in a direction of x decreasing. Therefore, negative sign will be taken. You may write here, the negative sign has been taken. The negative sign has been taken. Because the particle is attracted, because the particle is moving, the particle is moving in a direction of x decreasing, in a direction of x decreasing. But x dot is the mathematical expression, for velocity. X dot is the mathematical expression for velocity in a direction of x increasing, in a direction of x increasing. In other words, the velocity increases when x decreases. It is moving in the direction, it is attracted towards O. O is attracting the particle. Consequently, the velocity will be increasing. X will be decreasing. In that way also you can say like that. The negative sign has been taken because the particle is moving in a direction of x increasing, x decreasing. It is attracted towards O. You may write the particle in a direction of x increasing, or that is moving. The particle is attracted. The particle is attracted towards O. Towards O. The particle is attracted towards O. It is attracted. After down, it is attracted towards O. X dot is the mathematical. Clear? In this case, we will write the negative sign. Perhaps there is no doubt about it. X dot is equal to minus of this one. X dot is equal to minus of this one. Just note it down. This means, x dot means, you may write dx by dt equal to minus root mu. You may write here cx root over c square minus x square. You may write like this. C square x square root over will be cancelled cx, and in the numerator you will get c square minus x square. C square minus x square. Dx will be equal to like this. This means minus x dx divided by root over c square minus x square equal to root over mu dt. Perhaps we should suppose this is star. I have forgotten what is the number of the of the equation. Therefore, I have written it as star. It may be 2 or it may be 3. Therefore, I have written it as number star. The equation number is this. Now, what is our aim? We are to find the time taken by the particle to reach a point which is at a distance c by 2 from the center of force to reach the point B. This distance is c by 2. Right. Let T naught be the time taken by the particle. Be the time taken by the particle. Let T naught be the time taken by the particle to reach the point B. That is, to reach a point. That is to reach a point in the line. OA, which is at a distance. C by 2 from the center of force. Which is at a distance c by 2 from the center of force, right? T naught is the time taken by the particle. Now, integrating star we get. We have to find the value of T naught. Integration minus x dx. It will be c square minus x square. This is equal to integration root over mu dt. X equal to, it will be t equal to. Initially at the point A, t equal to 0. Initially at the point A, the distance from O was c. Therefore x is equal to c. When the particle reached the point B, the middle point of the line OA, then the time taken by the particle is equal to T naught. The time taken by the particle is T naught. When in that position, what is the distance of the particle from the fixed point? It is c by 2. It was c by 2, right? It was c by 2. Now integrate this one. Very simple integration. Well, just write the right inside. Root over mu. Come on. What is the integration of 1? T. 0 to T naught. It will be T naught. Equal to c square minus x square equal to z square. Right. Therefore, minus twice x dx will be equal to minus z dz. Minus twice z dz. Minus x dx is equal to z dz. Minus x dx will be equal to z dz. Therefore, it will be z dz divided by z. Z dz divided by z means simply integration dz means 1. The integration of 1 is z. What is z? C square minus z square. Therefore, it is root over c square minus z square equal to z means root over c square minus x square. It will be equal to c to c by 2. C to c by 2. You may write like this because you may put here c square minus x square is equal to z square. This means minus twice x dx equal to twice z dz. This means minus x dx equal to z dz. Minus x dx is equal to z dz. Therefore, integration minus x dx by root over c square minus x square, c square minus x square will be equal to, z dz. It will be z. Simply, this is equal to integration dz equal to z. It will be z. What is z? Z is equal to root over c square minus x square. C square minus x square. Simply, you may write this. This means root over mu T naught equal to root over c square minus c by 2 whole square. C square minus c by 2 whole square. You may write like this. c square minus c by 2 whole square. This minus root over c square minus c square, it will be 0. This means root over mu t naught equal to root over c square minus c square by 4 minus 0. C square minus c square by 4 minus 0. This is equal to root over thrice c square divided by 4. This is equal to c by 2 into root over 3. Root over 3. And in the left hand side it was root mu t naught. This means t naught equal to c. Oh, I am very sorry. I am very sorry for that. It was c square. This means that some terms have been left out. C by 2, another c should have been there. Another c should have been there. Just 1 minute. Just 1 minute. Just 1 minute. V square equal to mu ch. This c was dropped. Root over c square minus h square. It was like that. This v square is equal to one by x square. It was like that. V square is equal to just I am writing this. V square is equal to this. This means V square is equal to mu c square x square c square minus x square. This means V equal to minus root over mu. Root over c square minus x square divided by cx. This means dx by dt equal to minus root over mu root over c square minus x square divided by cx. This means this c was dropped. Yes. Minus x dx divided by root over c square minus x square equal to I wrote root mu dt, but it should have been root mu divided by c dt. I wrote it as just rewrite this one. From this v square is equal to this. We got this equation. V square is equal to this. After that, I wrote this one. After that, v equal to this. The negative sign has been taken because the particle is moving in a direction of x decreasing. V equal to this. After that, dx by dt equal to this. That c was dropped. This c was dropped. Please write this c. Now integrating minus x dx divided by root over c square minus x square. This is equal to root over. It should have been root mu by c dt. X equal to c. Here t equal to 0, t equal to t naught. It should have been c by 2. Just like this. It is very simple. The simple mistake was there. Just simple mistake. C was dropped. Just write this c again. This means root mu by c. Others are as usual. T naught. It will be definitely t naught. Just as before. It is root over c square minus x square c to c by 2. This means root over mu by c t naught equal to c square minus c square by 4 under root minus 0 c square minus c square under root. This means root over mu by c t naught. This is equal to thrice c square by 4 under root. Thrice c square by 4 under root. This means root over mu by c t naught equal to root 3 by 2 into c. Root 3 by 2 into c. This means t naught equal to root 3 by 2 c square into 1 by root mean, or you may write it as c square by 2 root over 3 by mu. You may write it like this. Therefore the time taken by the particle to reach a distance c by 2 is this. Just we have proved this. Very simple question. Very simple question. Just a simple mistake was done. C was dropped, and the correction has also been done. Therefore, there should not be any problem to understand this question. There should not be any problem to understand this question. I hope you have enjoyed this and you have understood everything is c square by 2 like this, right? Therefore the particle, I may write therefore the time taken by the particle, to reach a distance c by 2 from the center of force, is half of c square root over 3 divided by mu. Proved. We have proved this one. It has been proved. The question number 9, we have proved question number 9. Solved question number 9 completely. Now I am going to solve the question number 10. Right now. What is it? A particle moving along a straight line possesses an acceleration equal to this when it is at a distance x from a fixed point O on the line. If it starts from rest, again the same condition. If it starts from rest at a distance a, this time a from O, so that it arrives at O with velocity dash a root over 6 mu after time 8 by 15 root over 6 divided by b. Just very simple question. Just let me. A particle moving along a straight line. Suppose O is the fixed point. Which is called the center of force. Fixed point. O is the fixed point. It is the center of force. And A is the starting point of the particle. And the distance between O and A is small a. It is given. OA. And the velocity of the particle at A, the starting point, the velocity equal to 0. It is also given. Suppose P is the position of the particle at time t. OP equal to x. This distance is x. And the acceleration is given to be equal to this. But acceleration x double dot stands for x double dot is the mathematical expression for acceleration. moving in a direction of x increasing. You see here it is in a direction of x decreasing. Therefore, we shall take a negative sign. Here, before this negative sign. Also, it is coming in the direction AO, and it will at the time it will arrive at O. Then the velocity of the particle, when it arrives at O, the velocity of the particle will be A into root over 6 mu. Number 1 question. Question number 2, the time taken to reach the center of force, that is the fixed point. That is time taken from A to O is 8 by 15 root over 6 by mu. We are going to prove this. First, let me write, let O be the center of force. Be the fixed point on the line. Fixed point, you may write it is as the center of force. A, the starting point of the particle. Starting point of the particle. Point of the particle. Where OA equal to small a. Here OA is equal to small a. Velocity of the particle. Velocity of the particle at A equal to 0. Velocity of the particle at A equal to 0. It is given. Velocity of the particle at A is given. Let P be the position of the particle at any time. Let P be the position of the particle at time t, where OP equal to x. At time t, where OP equal to x. OP is equal to x. The equation of motion of the particle is. The equation of motion of the particle is x double dot acceleration x double dot. It will be minus mu a to the power 5 divided by x square whole to the power 1 by 3. It will be like this. The negative sign has been taken because the particle is moving in a direction of x decreasing. But x double dot is the mathematical expression for acceleration moving in a direction of x increasing. Therefore, negative sign has been taken. That's all. Now, just as before, you may write it as v dv by dx. V dv by dx equal to minus mu. You may write a to the power 5 by 3 divided by x to the power 2 by 3. You may write like this. This means v dv equal to, this means v dv equal to minus mu a to the power 5 by 3 x to the power minus 2 by 3 dx. Integrating we get integration v dv. This is equal to integration minus mu a to the power 5 by 3 x to the power minus 2 by 3 dx plus C1, where C1 is the constant of integration. Where C1 is the constant of integration. Where C1 is the constant of integration. This means from here you you may write number 1. V square by 2 equal to minus mu a to the power 5 by 3 x to the power minus 2 by 3 plus 1. Write it as minus 2 by 3 plus 1 minus 2 by 3 plus 1. You may write like this, plus C1 plus C1. Now let me write in this part. Now this means V square by 2, this is equal to minus mu a to the power 5 by 3, it will be x to the power 1 by 3 divided by 1 by 3 plus C1. This means V square by 2 equal to minus thrice mu a to the power 5 by 3 x to the power 1 by 3 plus C1 plus C1. One thing, don't need to write it as number 1, write it as number 1. This equation is at number 1. Right? Very simple differential equations, very simple integration will be this. Now we have to find the constant of integration from the initial condition. Initially the particle was at A. Initially at A. Velocity equal to 0 when x equal to A. Velocity equal to 0 when x is equal to A. Velocity equal to 0 when x is equal to A. Right? Therefore from 1 we get. No need to write 1 implies. This means that therefore from 1 we get 1 implies. 0 equal to minus thrice mu a to the power 5 by 3 a to the power 1 by 3 plus C1. 1 by 3 plus C1. This means C1 equal to thrice mu a to the power a square. It will be a square because a to the power 5 by 3 plus 1 by 3, because 5 by 3 plus 1 by 3 equal to 6 by 3 equal to 2. That's all. C1 is equal to thrice mu a square. Therefore substitute the value of C1 in 1 we get. Therefore 1 implies. Substitute the value of V square by 2 equal to minus thrice mu a to the power 5 by 3 x to the power 1 by 3 plus thrice mu a square. Thrice mu a square. This means V square by 2 equal to thrice mu common. Thrice mu, take it common. You may write a square minus a to the power 5 by 3 x to the power 1 by 3. Or you may write V square is equal to 6 mu a square minus a to the power 5 by 3 x to the power 1 by 3. Or you may write V square equal to 6 mu a to the power 5 by 3. You may write here a to the power 2 minus 5 by 3 minus x to the power 1 by 3. Or you may write V square is equal to 6 mu a to the power 5 by 3, a to the power 6 minus 5 means 1 by 3 minus x to the power 1 by 3. You may write like this. Suppose this is number 2. This is number 2. Now you have arrived to a position to find the velocity of a particle when it reaches the center of force. Right? Now let V naught be the velocity of the particle. V naught be the velocity of the particle. When it reaches the center of force, reaches the fixed point O, fixed when it reaches the fixed point 2, when it reaches the center of force, V naught is the velocity. We have to find the value of V naught. Therefore, putting V equal to V naught, X equal to 0 into we get. If you put X is equal to 0 here, then you will get V naught. Then you will get the velocity of the particle when it reaches the center of force. The distance from O to O is equal to 0. Therefore, from 2, therefore into we get V naught square equal to 6 mu a to the power 5 by 3 a to the power 1 by 3 minus 0. 1 by 3 minus 0. This means V naught square is equal to 6 mu a to the power 5 by 3 plus 1 by 3. This means V naught square is equal to 6 mu. It is nothing but a square. This means V naught equal to A into root of R 6 mu. It arrives with velocity. Therefore, the particle arrives. Therefore, the particle arrives the point O, fixed point O, with velocity equal to A root of R 6 mu. The particle arrives the center of force, the fixed point O, with velocity A root of R 6 mu. This part has been proved. Now we have to prove the second part. After time, we have to show that the time taken by the particle to reach the center of force O from the starting point is 8 by 15 root over 6 divided by mu. We have to show this one, the second part. Let us come to the second part. Perhaps you have noted everything. Thus, from 2 we get V. This is equal to X dot equal to, you will have to write minus A to the power 5 by 3 root of R A to the power 1 by 3 minus X to the power 1 by 3. You may write like this. The negative sign has been taken because the particle is moving in a direction of X decreasing. X dot stands for the velocity of the particle. The X dot stands for the velocity of the particle moving in a direction of X increasing. But it is moving in a direction of X decreasing. Therefore, the negative sign has been taken. The negative sign has been taken. Right? You may write here also. X dot equal to this one. This means dx dt equal to minus root of R 6 mu A to the power 5 by 3 into root of R A to the power 1 by 3 minus X to the power 1 by 3. A to the power 1 by 3. This means yes, root of R 6 mu A to the power 5 by 3 dt equal to minus dx divided by root of R. You may write like this. Suppose this is number 3. This is number 3. Let T naught be the time taken by the particle. Let T naught be the time taken by the particle. To reach the. Let T naught be the time taken by the particle to reach the center of force O, to reach the point O. From A. Let T naught be the time taken by the particle to reach the center of force O, to reach the point O from A. T naught is the. Therefore, integrating 3 we get. Therefore, integrating 3 we get. We get integration root over 6 mu a to the power 5 by 3, a to the power 5 by 3 dt equal to integration minus here dx divided by a to the power 1 by 3 minus x to the power 1 by 3 t equal to here x equal to initial position. Check the initial position. When the particle is at A, then time was 0. Time 0. At that time, x equal to the distance of A from O was A. X is equal to A. When it reached the center of force O, the time taken by the particle is T naught. It is T naught. And when the particle reaches the center of force O, x will become 0. It will become 0. Right? Thus, you will have to integrate this. This means root over 6 mu a to the power 5 by 3 into T naught. Simple. It is constant. It can be taken outside the sign of integration sign. 1 integration 1 dt will be equal to d 0 to T naught. T naught minus 0. It is T naught. Like this. Also, in case of definite integral, if the limit is changed, then a negative sign should be multiplied. Then a negative sign should be there in the integration. Already a negative sign is there. Therefore, it will be a positive sign. Therefore, this is equal to positive 0 to A dx by root over a to the power 1 by 3 minus x to the power 1 by 3. Suppose this is number 4. Suppose this is number 4. We have applied a definite integral, which is since integration a to b fx dx equal to minus integration from b to a. This definite integral has been applied here. A to b fx dx equal to minus integration b to a fx dx. It is minus sign. Change the limit. A to 0 to 0 to a. The negative sign should be removed. At the same time, negative sign should be removed. Now, let me write here. This means root over 6 mu a to the power 5 by 3 into T naught equal to no. We have written it as number 4. We have to find the integration of this. It's very simple integration. What should we put? X to the power 1 by 3 equal to 1 a to the power 1 by 3 sin square theta. Put x to the power 1 by 3 equal to a to the power 1 by 3 sin square theta. This means you will have to put x is equal to a sin to the power 6 theta. This means dx is equal to 6a sin to the power 5 theta cos theta d theta. x equal to 0. This means theta is equal to 0. X equal to a implies theta is equal to pi by 2. From here, put everything here. Theta is equal to pi by 2. Therefore, from 4 we get. Therefore, 4 implies. It will be root over 6 mu a to the power 5 by 3 t naught. We are going to find the value of t naught. This is equal to integration theta equal to 0 to pi by 2. Dx means 6a sin to the power 5 theta cos theta d theta. It will be a to the power 1 by 3 minus a to the power 1 by 3 sin square theta. It will be like this. Now, this means root over 6 mu a to the power 5 by 3 t naught should be equal to integration 0 to pi by 2 6a sin to the power 5 theta cos theta d theta divided by a to the power 1 by 3 common. Root over is also there. A to the power 1 by 6 will be there. Root over 1 minus sin square theta means cos square theta. Root over means it is cos theta. It will be like this. Is it 5 by 3? Yes. This means root over 6 mu a to the power 5 by 3 whole to the power half. You may write like this. T naught equal to 6 a to the power 1 minus 1 by 6 into integral 0 to pi by 2 cos theta will be cancelled sin to the power 5 theta d theta. You may write like this. This means root over 6 mu a to the power 5 by 6 t naught equal to 6 a to the power 5 by 6. It should be 4 by 5 into 2 by 3 into 1. Using reduction formula, you will get 3, 2. A to the power 5 by 6, a to the power 5 by 6. These two terms will be cancelled. This means root over 6 mu into t naught equal to 16 divided by 5. 16 divided by 5. This means t naught will be equal to 16 divided by 5 into root over 6 mu. Root over 6 mu. This means t naught equal to 16 into root over 6 divided by 5 into 6. 5 into 6 into root over mu. You may write like this. Now 6, 3, here it will be 8. T naught equal to what we have written 6, 5 into 6 into root over mu. It will be 3, it will be 8. Is not it. This means T naught equal to 8 by 5 into 3, 15. Root over 6 divided by mu. Root over 6 divided by mu. 6 divided by mu. Therefore, the particle will arrive at O after a time. This it has been put 8 by 15, root over 6 by mu. Therefore, the particle will arrive. Therefore, the particle will arrive the point O, arrive at O. FO after a time. A time. What is the time? 8 by 15 root over 6 by mu root. Dear students, perhaps you have enjoyed the class. Thanks for attending the class. Thank you very much. Thank you.